All right, today's lesson is lesson 5.5, and we're going to be talking about slope applications. You know, I'm not going to get away from applications anytime soon. The word application just means word problems, like real life scenarios. How can we use slope? And people do use slope for multiple things, okay? So let's check it out. Number one says the table below shows the high temperatures in degrees Fahrenheit of a city during its first part in June, okay? So think about the date is my X value and the high temperature is my Y value, okay? So we're going to use the information from the table to answer our questions. And just to recall the slope formula, remember it's Y2 minus Y1 over X2 minus X1. All right, so first off, find the rate of change in high temperatures between June 1st and June 6th. So that means I'm literally just using these two ordered pairs, okay? So my ordered pairs are 1, 72 and 6, 76. Right, so you remember I said to take a second and just go ahead and label your X2, Y2, X1, Y1. Okay, now we can just plug it into the slope formula. 76 minus 72 over 6 minus 1. 76 minus 72 is 4. 6 minus 1 is 5, okay? So because we're talking about a real value with a real problem, I want to actually divide this to numbers. So take 4 divided by 5, and you get 0.8. That's how many degrees it changed per day. So 0.8 degrees per day. All right, that wasn't so bad, right? All right, so part B says find the rate of change in high temperatures between June 6th and June 8th. Well, now I'm no longer using this ordered pair. I'm going to go ahead and circle this one. So now I'm going to use those two. So 6, 76, 8, 84. All right? There's my X1, Y1, X2, Y2. 84 minus 76 over 8 minus 6. 84 minus 76 is 8. 8 minus 6, 2. That gives us 4 degrees per day. Well, this definitely changed a lot between the 6 and the 8 versus the 1st and the 5th. All right, now it says, C, during which of these time intervals did the time rise the fastest? Well, the bigger the slope, the quicker it's going somewhere, right? So I just said that, right? So the temperature, I'm going to abbreviate, the temp rose faster between June 6th and June 8th. Nice. Done. Answer my questions. Whoop, whoop. That wasn't so bad. You know what I mean? All right. Let's check out example number 2. All right. Josh started a diet and decided to record his weight every other week. Okay. Here is my X. Here is my Y. Let's see what we can do. We're going to find the rate of change. Rate of change is just another word for slope between weeks 0 and week 2. So here's my ordered pairs. 0, 224 and 2, 219. All right, so we plug it into the slope formula. 219 minus 224 over 2 minus 0. That gives me negative 5 over 2, which, because we are talking about application problems, we're going to go ahead and simplify that even farther and get negative 2.5 pounds per week, so we can answer the question. Right, so that means he lost, between those first 2 weeks, he averaged about, well, not averaged, but he lost 2.5 pounds per week. All right, so B, we're going to find the rate of change between week 2 and week 4. So I'm going to erase week 0, the starting week, and we're going to circle week 4. Let's see what happened here, right? So now my ordered pairs are 2, 219 and 4, 221. Let's plug that into the slope formula. 221 minus 219 over 4 minus 2. It gives us 2 over 2, which is 1. So it looks like a gain. So this rate is 1 pound per week. All right, remember, these are pounds per week, because that's the chart. That's what it's talking about, pounds per week. So C says we're going to find from week 4 to week 6. So let's erase 2. And circle 6. Okay, so now my ordered pair is 4, 221 and 6, 215. All right, let's check it out. So 215 minus 221 over 6 minus 4. 215 minus 221 is negative 6 over 2, which is negative 3 pounds per week. Well, that's good. At least you got back on it. You know, that's how weight loss is. It's ebb and flow, baby. You got to give to get. All right, so that's not so bad, right? Using the information from the table, plug it into your slope formula. Here it is again, in case you forgot. You know, maybe get in the habit of writing it down so that you always can remember it, right? So that it's like permanently in your brain. All right, part D says, find the rate of change between week 6 and week 8. Explain what this means. So as I've been going through, I've tried to like kind of understand this information. When I see a negative, that's a weight loss. When I see a positive, that's a weight gain. So let's see what happens here. So 6, 215 over 8, 215. Okay, that's kind of crazy. All right, so let's go here. 215 minus 215 over 8 minus 6 is 0 over 2, which is 0 pounds per week. What does that mean? Well, that means he didn't lose any weight, right? His weight didn't change. The weight didn't change. Yeah, right. Moving on the back side. Here we go. We got some graphs. All right, the graph below shows the number of miles driven after each hour of a road trip, right? These are ordered pairs, these little points here on this graph. Okay, so A says find the rate of change, which is the slope, from hour 1 to hour 4. Well, notice, let's look at our number line here at the bottom, x-axis. Okay, there's nothing here. That's 0, right? So that would make this 1, this is 3, here is 5, 7, 9. Okay, so now we can see where hour 1 is. Hour 1 is right here. Hour 4 is right there. So the ordered pairs associated with those 2 points are what we're going to use to find our slope. So hour 1 is 1, 60, and hour 4 is 4, 160. Plug that into our slope formula, 160 minus 60 over 4 minus 1. This is 100 over 3. And again, we are talking about real word problems. So we're going to go ahead and divide 100 divided by 3. That is 33.3 repeating miles per hour. That is the answer. Okay, that's how the answer should look. All right, B says find the rate of change between hour 8 to hour 10. Well, let's go ahead and get rid of these. We're not using those points anymore. Now we're going to circle hour 8, which is right here, and hour 10, right there. Those ordered pairs. Okay, also, we have a gap here. We don't know what this is. How would we figure that out? Well, if you look here, this is 360. This is 460. That's 100 between them. Half of 100 is 50, so if I add 50 to 360, that makes this 410. We need that. Okay, so now my first ordered pair is 8, 410. And my second ordered pair is 10, 460. Oh, that was weird. Sorry. So 460 minus 410 over 10 minus 8. That gives us 50 over 2, which is 25 miles per hour. All right, that was easy. That was pretty easy. All right, let's look at another graph, okay? So we have number 4 below that. Here's our points again. Okay, we need to be really careful about our x values, okay? Oh, is it this one? Maybe not. No, it's not this one. I'm sorry. I'm jumping the gun here. Okay, the graph below shows the change in the water depth of a lake through various years. So these are the years below, and this is the water depth, right? This is my x-axis, and this is my y-axis. So it says from 2000, that is here, or this point, to 2004, which is this point, okay? Again, we're going to have to figure out what our y value is here. So first off, we need to subtract. What's the difference between 58 and 66? 8, right? Well, half of 8 is 4, so if I add 4 here, this is 62. We just want to find that middle. All right, so my first order pair is 2000, comma 62, and my second order pair is 2004, comma, well, we know we had to add 4, this is 78 here. All right, so 78 minus 62 over 2004 minus 2000. 78 minus 62, that is 16. 2004 minus 2000 is 4. When I divide those two, that is 4. So this is 4 feet per year. You want to make sure that your labels match the labels of your axes. All right, B says find the rate of change from 2012 to 2016. Well, let's get rid of these points. We're not using those anymore. All right, 2012 right here. 2016 right there. All right, we need to find our y value. Remember, each one of these blocks is 4, so this is going to be 46. So our first order pair is right here, 2012, comma 62. And, sorry, I was like, oh my God, it's the same y value as the one in 2000. That's okay. And the next one is 2016, and that y value is 46. All right, so 46 minus 62 over 2016 minus 2012. All right, plug that in. That gives me negative 16 over 4, which is negative 4 feet per year. Interesting, interesting. The water depth went down. It rose here in part A between 2000 and 2004, and then it drank. Maybe there was a drought or something happened there. Interesting. All right, let's look at some more math problems, applications. Okay, I'm going to try to make this a little bigger. I'm having a hard time writing. There we go. Nice. Okay, good for me. Here we go. Ava started a savings account with $500. Okay, so when something is starting, that means X is 0. That's your starting point. It's like, think about when you're born. You are not 1 when you're born. You're 0 years old, okay? That's the starting. So let's pick our first order pair with that first line. 0, $500. Now it says after 6 months, her savings account balance was $731. We need to find the rate of change. So 6 months, that's going to be our X value here. And now she has $731 in her account. Let's find the slope. Find the rate of change. 731 minus 500 over 6 minus 0. That gives us 231 over 6. When we divide, remember, because these are real word problems, we actually have to have real answers, we get $38.50 per month. Okay, remember the other units we were using because they were 2 words like miles per hour or feet per year? The dollar sign is a unit, dollars per month, okay? Remember that little slash in the. All All right, that's it. We answered it. Yay, that wasn't so bad. It was not so bad at all. All right, number 6. An airplane is flying at an altitude of 36,000 feet when it begins its descent to land. Okay, so it's beginning. So the first ordered pair is going to be 0, 36,000. That's when we're going to evaluate. That's where we're going to begin our evaluation. Okay, so that's why your x value is 0. When it began. The beginning. Remember, beginning, x equals 0. Okay. 12 minutes into its descent, it is at 29,400 feet. So 12 minutes, that's going to be our x. 29,400 feet, that's going to be our y. So let's do the slope. 29,400 minus 36,000 over 12 minus 0. That gives us negative 6,066. Oh, sorry. Negative 6,600 over 12. Once you finally divide, you get negative 5,000. Hold on, I need to get my calculator. I think I need a mistake here. We get negative 550 feet per minute. Because remember, slope, the rate of change, you're comparing two things, x and y, right? What's representing what? Here, it was dollars and months. This one's feet and minutes. Okay, I need to make a correction on my paper. I definitely made a mistake there, but that's one mistake. All right, what I want you to do, well, first off, I'll set up the order pairs, but I'd like you to practice this on your own. I mean, I guess you're going to get your homework. I don't know. Fine, let's do it together. All right, number 7, 10 minutes into her workout, Laura had burned 98 calories. So she's 10 minutes into her workout. That is not, she just started her workout. So our first ordered pair is 10, 98. Then it said 25 minutes in, she's burned 272 calories. So 25 and 272. Find the rate of change in calories burned between 10 and 25 minutes. Well, we've just been doing slope like a goat. We can handle this. 272 minus 98 gives us 174. 25 minus 10 is 15. When we divide these numbers, we get 11.6 calories per minute. I'm going to need to burn a lot more than that to get rid of all that I've gained from Thanksgiving. Just kidding. Okay, here we go. Last one. The population of Beaufort was 16,200 in 2010 and 13,824 in 2016. We are going to find the rate of change in population. Literally, here is our ordered pair, but time is our x here. Time is our x. Okay? The time is independent. So the first order pair is 2010, 16,200. And the next order pair is 2016, 13,824. Okay, we just simply plug these numbers in. 13,824 minus 16,200 over 2016 minus 2010. I keep wanting to write 210. All right. Remember, n that represents our slope. I haven't been doing that. I'm sorry about that. All right, when I subtract 13,824 by 16,200, that gives me a negative 2,376. 2016 minus 2010 is 6. And when I divide to get my real answer, that gives me negative 396 people per year. There's our answer. Look at that. We nailed it. So good. Not so bad, okay? So I know you guys see words, you get all freaked out. Don't freak out. You got this. You're going to be fine. Let me know if you have any questions. All right. Have a great day. Bye.